I'm going to start off with going through a few setup guide tutorial items before using the tool that I've developed. This tool is much more than just the Python that I've developed into a GUI. It involves interacting with Google Earth Engine and their Python API to interact with this data. Their Earth Engine catalog involves many different efforts across the world aggregating satellite data for many different use cases. And this particular one for the Sentinel-5 series comes from the Copernicus mission led by European Union programs. So I was inspired this year to start investigating more access to greenhouse gas emission data. And this came about from articles that I came across looking at the decrease in human activity because of lockdown and COVID-19 crisis, correlation between higher mortality rate in cities where pollution was known to be worse, respiratory illnesses associated with greenhouse gas and atmosphere conditions. So with that, QGIS, again, is a quick and easy way to look at geospatial data. It's built in C++ and Python, and Qt is sort of a tool that you can use to build GUIs like this. So the Copernicus program is atmospheric measurements, marine environments, land and water levels, all of this to sort of monitor climate change. And they listed right on their website that this data is freely available and is meant for anyone from scientists to policymakers to entrepreneurs. And this mission in particular launched October 13, 2017. Earth Engine is a multiple petabyte catalog of satellite imagery. And this is only one subset of it. This is available for scientists, researchers, and developers for free, again, with the caveat that there are many limits to the requests you can make to the database. So they limit it if you're above this certain number of elements that you're trying to pull from the database, or a byte size limit. But it's broken up into three different categories. They have individual images, as well as image collections and feature collections. Now, I've focused on image collections and feature collections because it's more conducive to pulling this data into text format, tabular analysis. And the feature collections are helpful in establishing sort of common boundaries. I'm talking about US states and counties, or world borders for countries, roads, population densities, these types of things. Very helpful with collecting atmospheric data in borders that make sense. So the purpose of this plugin is to sort of build off of more of the prior work. So investigating other plugins that have already tried to tap into the Google Earth Engine database from QGIS was extremely helpful in knowing the missing steps were for someone like me that is still trying to get familiar with how to use Google Earth Engine. You have to sort of guess and check, and this can take quite a large amount of time if you're really off the margin. So I've kind of tried to build different functions to resize these requests automatically, so that you can preview a data set, and this all happens internally. Preview the data set in order to get these metadata parameters, which are defined if your request is of the right size, and pull out those sort of metadata parameters in order to help guide you towards where you should be looking to get the actual data, because otherwise you just get nothing back. There's no response from Google Earth Engine, and that can be very frustrating. Upon looking at some of these other plugins, one of them is simply a wrapper for the Python API, which is one of the dependencies of this plugin. Somebody has already gone through and mapped the one-to-one mapping of code from QGIS to Python. It has the same frustrations if you don't know what you're doing, like myself, of developing directly onto the Google Earth Engine platform, where if you don't know about the data set that you want to look at, you're going to have all the same problems with returning empty results. Another plugin looks at more Sentinel images from previous missions that they've sent up, and these are more individual images. So these are extremely helpful when you want to see different types of satellite images, more than just the standard sort of Google Earth or OpenStreetMap. So I didn't want to repeat their work since they've put a lot of effort into that. So this is sort of building on to other data sets that they have not covered yet. So the first steps you can do are to sign up for a Google Earth Engine developer account. And again, this is free, anybody can do it. This allows you to use their platform, their web-based developing platform, to see it for yourself and try and see if this plugin even makes sense for you. If you already know what you're doing, then you might not need it. The QGIS download is an easy to do thing from any platform. Here's the quick link to the site. And the plugin is still in its experimental phase, but it is free to use. It's on my public GitHub repository. And I go through the process of how to download it and install it as an experimental plugin within QGIS since it's not yet in the full list of plugins at this time. So the Google Earth Engine Python API wrapper is in the list of plugins that are available, and you can find it here. Search for it and install it. It's as easy as that. Once you have that dependency downloaded, then you can start using the plugin that I've developed. So I've put in a few of the dependencies of what's happening in the Python code, and actually one of these has been removed. I've found a way to get around needing to package install one of these modules. But so Beautiful Soup 4 uses web scraping to figure out the catalog on the Google platform to get just the first set of data sets to choose from. GeoJSON was just replaced by regular JSON. And I picked this format because you can actually take the same geospatial data in and out of any GIS program and just look at the raw text. So if you want to take this into an Excel or your own code editor of your choice, you can look at the data and you don't need any sort of proprietary key to decrypt it. The plugin covers 92 out of the 409 datasets, and these include 48 image collections and 44 feature collections. I've developed sort of a filtering system to query these datasets based off of embedded tags, the dataset type, whether it's the feature or the image, the publisher of that dataset. So for the previous one, Copernicus, time, geospatial filtering, and on top of that, I just built some easy buttons. One of them uses your IP address to find your ISP location, and you can start building a geospatial filter from there. If you don't know your latitude, longitude off the top of your head, this will find it for you. Now, this does ask you for its permission to do it before locating you, so you're perfectly fine to deny this application. I also build a few automation steps to help extract the details of the dataset. So it queries the preview and pulls out where the description is of the dataset so that you can view it within the QGIS tool. You don't need to go back to Google Earth Engine and look it up. Once you save your vector data, it automatically plots it. You can pick the bands individually from an image collection to sort of reduce your request size. So this is also extremely helpful. I'll also figure out the default palette that Google uses to display this geospatial data. And you can, of course, customize this if you don't want to use the default. Two last items that I go through that are extremely helpful of getting any of the data back: resolution scaling and error guidance. So I do sort of some napkin math to inform you why your request is failing, if it's possible, if it's failed the right way. What I look at is from your request, how many images were you trying to get within that date frame? And within the region that you're covering, what is the total area versus the resolution that you've asked for? And how many requests does that take to get the total number of data points in that set?